All right, long awaited, Chapter 8, Human Population. I want to make sure that we just kind of screen through some of the things that you need to know. I know that you've solved a lot of these problems already, but I just want to give you a little bit of focus on human population. So here we go. So the core case study that talks about it talks about in chapter 8 is basically us, the evolution of Homo sapiens, and how the population has really taken off in the last 200 years, really. But we've got total population of 2 billion. It took 200,000 years to get there, and this is the point: is like growth as we have developed as a human society has become much faster, and people don't we're not dying off. So it took less than 50 years to add another 2 billion, and then 25 to add a third 2 billion. 8 years later, the Earth has 7.5 billion people. So this is an example of exponential growth. We have not reached that carrying capacity level yet. Factors that impact rapid rise of human population are the emergence of agriculture, because it's an increased food production component, technology that helps humans expand almost all of the Earth's climates and habitats. We are able to live anywhere, and there's a drop in death rates, obviously, with improved sanitation and healthcare. But the question really stands: what is sustainable? 8.1 talks about how many people the Earth can support. So this is going into that question of what is actually sustainable. Throughout most of history, population rose really slowly, and over the last 200 years, like I said, it's grown really fast. China, India, and the United States are the top 3 countries in terms of population, in that order. The rate of population growth has slowed since 1960 to about 1.2%, but the world's population is still growing. Human population growth is unevenly distributed geographically. 2% are added to more developed countries, whereas 98% of the population growth is relegated to the less developed countries, which is a stress for them. And it also means when you are fighting for your life and maybe haven't developed as a society, means for dealing with trash and wastewater in a way that is not impacting the environment, that it can have a really detrimental effect on the environment. And that does affect the more developed countries. So we are not separate in this. People are moving from rural areas into urban areas to find jobs. Here is a graph. I want to see what showing the population growth rate percent. I want to read the little caption thing for it, but I don't think it's going to let me. And then as population growth rate has dropped off, our population size has still grown, and we're here right at the red, and we definitely are anticipating that even though the growth rate is dropping off, population still grows because of the technological advances that we put into place. So here's another forward thinking, just to kind of show you like what's happening. The population is it's mostly growing in in less developed countries. So you can see that that's the big swell. With that comes innovation and development, and hopefully the countries that are developing now with the knowledge of human impact on the environment are going to make some smarter decisions about what direction they're going to take their countries in terms of how they impact the environment. That science focus, how long can human population keep growing, is in 8.1. It really follows on that core case study. So there's a lot of different views. Some think that we've already exceeded tipping points or planetary boundaries and that we're beyond carrying capacity, and that's all we've got. Hang on, somebody's at the door. Okay, back at it. The main problem is that rapidly growing numbers of people are in less developed countries. That's another opinion. This is why it's happening. And then there's another view that the main problem is overconsumption of the more well-developed countries. And then there's even this other idea, like how do we respond to this? Technological ingenuity will help us find substitutes to the resources we're depleting. Like, it's hopeful. I think I'm somewhere within all of those viewpoints. I think that we need to stop over-consuming in more developed countries, that technology is necessary, and I'm hoping we'll get something there. I think we have gone beyond the tipping points, or at least we've gone beyond the planetary boundaries, and that we need to come back in terms of the draw that we have and the energy we demand, as we know that is a finite number. Only so much energy comes in, only so much is captured. So as a planetary cohesive ecosystem housing us as a very advanced and demanding species, how many of us can actually be how long can it sustain this way? That's the question at hand. Proponents of a slowing population growth, this is like arguing for it, right? Excuse me. That the basic needs of 1 billion people are not being met, and there is a reason for us to slow population. Death rates could increase significantly, and a population crash could result, or we could get a pandemic. As China, India, and Brazil increase their ecological footprint, a greater resource use and environmental degradation may result. And we're seeing that. We're seeing that with the loss of forests and not, like climax communities. Like it's just not the same to replace a forest with a monoculture palm oil plantation. Human population grows, and as it grows, so does the human ecological footprint. There is such a thing as like this cultural carrying capacity, this idea that maximum people who could actually live in responsible freedom, and this, like what we refer to as like quality of life, right? And that we need to institute some kind of limit, but it's really hard to regulate. And these are some of the things that we know degrade the environment, and in that degradation, we see a reduction in biodiversity. When we increase the use of net primary productivity, which that means like we're taking down plants, right? We are also seeing an increasing genetic resistance in pest species because of our agricultural practices. We are eliminating many natural predators because we're taking away their land. They can't find what they need to hunt. A lot of our apex predators use large territories, and when humans encroach on those territories, they've got nowhere to thrive. We have many examples of introduction of harmful species for invasives. And some renewable resources, we're using those faster than they can be replenished. So are they actually being managed in a renewable way? We disrupt the natural chemical cycling through the introduction of like synthetic fertilizers into waterways, the use of water for treating sewage, or all sorts of stuff. Relying mostly on polluting and climate changing fossil fuels for our energy puts us kind of like, that's the coup de grace, right? Like that is how we are degrading our environment the most. So how do we change those things? That's kind of like the big question. Population size increases. That's like the call to do something. But now we're going to move into 8.2, which has more to do with the math. Okay, population size increases through birth and immigration, and it decreases through deaths and immigration. And that that's that simple calculation, the one that you had on your page that was wrong. You got to switch the I and the E. So just remember births and immigration, additions and subtractions, deaths and immigration. A key factor that determines population size is the average number of children that are born to women within a population. This is referred to as the total fertility rate. So there's a definition that you need to be aware of. I know that you've got these. And I want to reiterate this, that crude birth rate is the number of births per 1,000 people. So you got to set up that ratio. Typically, we set up that ratio by taking births per population, the total population. So the total number of births, total number of population. And then we set it into a ratio by finding a decimal and then multiplying that by 1,000. And the reason we can get back to 100 is we divide it by 10. And I know that caught some of you guys off guard, but remember, you're just setting up a ratio. Percent is a ratio. You find the decimal, multiply by 100, that gives you a number per 100. Crude birth rate's no different. You just find that decimal and then you multiply by 1,000, and it's going to give you that number per 1,000. And then what we do with it gets a little bit less disciplined in terms of mathematics because it's social science. Replacement level fertility is the average number of children a couple must bear to replace themselves. The average is 2.1 just because some children die before reaching reproductive years. We talk about total fertility rate, average number of children born. Between 1955 and 2012, the global TFR dropped from 5 to 2.5. To eventually halt population, the global TFR must drop to the replacement level of 2.1, and it's got to stay there. It's got to be sustained. So you can see these are fertility rates, historic fertility rates from like the early part of the century in the 15s out about 1915 and on. You see a rise in fertility rate in the baby boom as the cultural response to World War II. And then as we dip down under replacement level, worldwide. We're hoping eventually, right, that we'll see a, a, a slowing of population growth. All right. Projecting population change is a very tricky endeavor. Human population size in 2050 is estimated to be somewhere between 7.8 billion and 10.8 billion. That's kind of a big gap, but it's really difficult to predict pandemics. It's very difficult to predict technology or innovations that they haven't been invented yet. We don't know if those could really impact. We don't know until they're invented, and then we see the impact on society. Factors that influence the range of estimates are reliability of what we have currently in terms of numbers. So we can only give that reliability, and there's got to be a percentage of like error that we account for, that we have to make assumptions about trends in fertility. And then there's different organizations who estimate populations. They use different methods, they use different data. Our data sets aren't really cohesive. So we get this big discrepancy. Plus, we have this idea that culture can change, and ideas about children can change, and workforce needs can change, and all of that. All right. So here's just another projection. These are different projections from different authorities, and you can see that they're quite discrepant. All right. So the U.S. population is the third largest population in the world. It's still growing. 76 million in 1900 to 322 million in 2015. There was a drop in the total fertility rate in the United States. This rate has slowed population growth. 40% of the total U.S. population increase in 2015 came from legal immigration. So we have this population growth that is happening for our country that affects what we need to do to plan for food and technology and infrastructure and education and all of those resources. But we have a growth that is actually reflecting like maybe slower growth in other countries because the growth is shifting into the United States. And so you can see that as we used to have classically a lot of growth because of immigration, and the Great Depression came, and now we've seen that increase over the past few decades again. Life expectancy in 2000 is really good in the United States now. You can see, just as a comparison, some of the statistics that population demographers pick out to kind of make these predictions about where a population is going, like how long people live is definitely part of that equation. Married women working outside of the home, when someone is working outside of the home, you'll have a tendency to see a delay in starting a family, and sometimes choosing to have less children. More high school graduates means you're going to school for longer, means you're delaying having children. Homes with flushing toilets means that your children aren't dying of cholera, and so you're less likely to feel a need to have a bunch of kids so that you have Social Security. Homes with electricity, people living in suburbs, you can see that there was definitely a cultural shift. Sadly, homicides do go up as population goes up. It's the rate at which they happen as well. Factors that affect birth and fertility rates. So the importance of children is part of the labor force, especially in less developed countries where somebody might be running a farm or a factory or a mine, as awful as that sounds. I'm not saying it's right, but I'm saying it is what it is. Cost of raising children and educating children is part of that equation. The availability of pension systems, so retirement. Are your children in your retirement, or are you able to put away money because you have that kind of job? Urbanization, educational employment, opportunities for women, average age of marriage, the availability of reliable birth control methods, whether or not you believe in birth control methods, these will all affect birth and fertility rates. I know that your FRQ mentioned Kenya. Kenya has definitely is a little bit earlier on the progression in terms of changes brought to these different issues, but you can see, according to this, that in the early part of the 20th century, the United States definitely was sharing some of these values, because you can see the evidence of that in terms of what rates were for some of the different outcomes that are affected by these issues in our population. So it's just a matter of development as a society. We kind of looked at that demographic transition, and that was definitely an issue. So there you just an example of a kid working, should be in school, we would say, but it's definitely a cultural difference. And as a society grows, typically the workforce is taken on either by machinery and technology, is able to be used to replace, children workers, but protecting the rights of children for education is part of the more developed countries. Indicators that overall health of a country is good are called life expectancy, right? How long you're going to live, and infant mortality rate. These are kind of the two big measures. These, obviously, this has to do with death rates. A number of babies out of every 1,000 who die before their first birthday is infant mortality. Factors that cause high infant mortality rate are usually connected to food or medical care during the, what's it called? Not postpartum. Okay, during pregnancy. I can't remember what it's called. I had 3 kids. Poor nutrition or infectious diseases, like from not having adequately clean water, that can cause high infant mortality rate, or sometimes pollution from industrialized areas that aren't being regulated properly. If toxins get into the waterway, can cause a lot of birth complications, birth defects, and a higher infant mortality rate. And that can come from like leather tanning and mining and anything that uses like heavy metals and toxics that end up getting not regulated and end up getting dumped in water, can affect the infant mortality rate of a country because it's affecting women who are pregnant. All right, factors that affect death rates. You can see infant mortality rate in less developed countries has come down. Overall in the world is coming down, and in more developed countries it was lower to begin with and is still dropping. So we are learning, as science is applied, we are learning what affects infant mortality rate in ways. There's medical innovations that we can introduce, but there's also environmental regulations and supply of nutrition. All of that comes into play. It's time for school. All right. Migration, the movement of people into and out of specific geographic areas. And this plays into total population of an area. Reasons for migration can be economic, they can be religious, they can be, like right now we have a lot of people moving out of Ukraine, oppression and war, or sometimes even environmental refugees that are coming from areas that are being degraded or affected by climate change. I know Madagascar is going through an extreme series of droughts that is like indicative of climate actually permanently changing there. So 8.3 goes on to talk about how what age structure is and how it affects growth or decline and how we actually look at it and analyze it. So age structure is the number and percentages of males and females in young, middle, and older age groups, and they're kind of, it's like 2 histograms. They're butted up against each other. I know we've already had you work on these. So this important factor. It's an important factor in determining how fast a population grows or declines, the actual age structure of a society, which is the metric, but then we have this cool diagram to kind of look at age structure. So the categories are pre-reproductive, so 0 to 14, reproductive, which is 15 to 44, and then post-reproductive, ages 45 and older. Now, males can continue to reproduce beyond 45, but we typically just apply that because based on cultural norms, being one woman, one man, that's usually a mother and father that are working together to raise children. And so we don't see a lot of older males fathering children, but it does happen. The country with the largest percentage of young people that are under the age of 15 or a country with large percentage of younger people that are under the age of 15 will experience really rapid population growth. Global population of seniors is expected to triple between 2015 and 2050 because we have lengthened life expectancy. All right, so here's some examples of age structure diagrams and what they actually mean. You have this expanding rapidly. You can see in Guatemala, and Nigeria, and Saudi Arabia are examples on the left-hand side. You have a very large pre-reproductive categories. The sides are kind of like curved more, okay? Expanding slowly, you have angular sides. a stable population, you actually see the size kind of squeeze in, and you almost get like a linear relationship on um, in the reproductive and the pre-reproductive years. And then a declining, there's actually where the trend is angling in, where there's less and less of a particular younger age, and that's indicative of a declining population. Take a look at the countries and where they sit in those. And remember this, that it's not just births that are affecting this. So if in one of those expanding populations, you have people moving in to that population and in those reproductive years, then they're adding to that particular metric category. All right. We know about the baby boom. Be aware of the baby boom. This cultural component from 1946 to 1964, 79 million people were added to the U.S. population. This makes up about 25% of the U.S. population. It affected politics, economics, it affected education. Now this particular generation is becoming, they are the senior citizens. It's referred to as the graying of America because we have this very large population. Excuse me. And then now the generation that the baby boomers had, the millennial generation, is now the largest generation living in the United States. So even if they were, if their total fertility rate within that particular generation dropped, there were so many baby boomers that even though they were having less kids, that population, that millennial generation, and that population still grew a lot. You can see here is kind of over time. So on the left-hand side from 1955 to 1985, 2015, and 2030, how that population has moved through the age structure, through the age structural components. Like you can see that in 1955, it represents the early years, and then they move up into reproductive age, and then out of reproductive age and into the senior citizen stages. Alrighty. Here's another example kind of overlaying how that growth has shifted from 1950 to 2010 and then 2050, and how the baby boom generation has kind of moved up each of those categories through the years, and you can see that shift. All right, aging populations can decline rapidly. Slow decline is generally manageable, and a rapid decline leads to economic problems. Okay, so when we have an aging population that's lived for a really long time, there's a lot of people to take care of. I know there's a care home being built just down the street from us because that's like a big industry right now as our population is aging. Some countries that have rapidly declining populations and are looking at labor shortages and not having anywhere to put people that need care and help. Japan, Germany, Italy, Bulgaria, Hungary, Romania, Cuba, and Portugal. And I know that some of these countries actually import workers to take care of their aging population. All right, you can kind of see some of the issues that arise because of that. You have to take care of this population as part of the cost of society. 6.4. I'm guessing that's probably 8.4. How do we slow population growth? There's a controversy on whether population actually needs to slow because of that lack of workers. Ways to slow human population growth, though, if we need to or want to, is reducing poverty through economic development. That's kind of the most positive approach. Elevating the status of women, the most positive approach, and encouraging family planning so that people can choose to have less children or to not have children at all. We talked about the demographic transition. This is an example of the demographic transition, kind of like typical issues that come. So you have at stage 1, pre-industrial, population grows slowly, but birth rates are high. That means that death rates are high, so infant mortality is high, and that you just get a slow growth in population. Those rates match each other. But then this transitional stage, which can be extremely long, is where population grows rapidly because birth rates are still really high based on practices from history, but death rates are dropping due usually to improved agricultural food production, the trade of food, a more stable economy, and then health innovations as well. And then industrial stage, we still see we have a slowing population growth, but it's still positive, still growing. as birth rates start to come down, because people don't feel the need to fill out their workforce, and then population growth levels off in the post-industrial stage, and we're even heading into this fifth stage that is a new idea. Okay, below this age structure diagram, I want you to see the correlation between, below the transition, the demographic transition model. I want you to see kind of the typical age structure diagram and make that correlation. That's what would be happening with the population, and in each of those age categories, that's what it would look like distribution-wise. Now, this is kind of like ideal. It's not always exactly like this, but this is definitely the pattern that we've seen in demography as societies have developed. Okay. So we did talk about threats to making a demographic transition are things like extreme poverty or war, and that sometimes you'll see countries that are heavily impacted by war, where maybe their industries are damaged, or you have like some large-scale natural disaster that can put a society back into an earlier stage of the demographic transition, and then they have to kind of rebuild and reinstate some of the things that would support getting into that post-industrialized transition stage. All right, so we talked about some of the things that do actually move societies from one area of the demographic transition to another. One of the big ones is that women will have fewer children if they're educated, if they're able to earn an income. Society does not suppress their rights. They don't feel like they have to birth a male child to go off and earn an income so that her security is taken care of later. Women do most domestic work and most childcare. If you provide unpaid healthcare, it's free. It's societal healthcare, and then they have. Oh, no. What is it saying? Okay, women are the domestic work and the childcare. They provide unpaid healthcare, and they have fewer rights and educational opportunities than women worldwide. Okay, it's still an issue, and so one of the easiest, most positive ways to influence population growth is by educating women. And then one of the outcomes of that is family planning benefits. That often when we educate women and supply them with medical care outside of what they're giving for themselves, family planning is a benefit of that. Sometimes there's a lot of fear surrounding family planning, especially in highly religious societies. And so getting educational materials into the hands of women is a really powerful component of shifting population growth. You can see this case study on the population growth in India. The population is huge, 1.3 billion in 2015. Some of the problems that have arisen out of India's population growth are poverty, malnutrition, and environmental degradation. They do not regulate industry as much as some other developing countries, and they have some really big rivers, and there's just a lot of issues that they're still working through. Most poor couples will want many children. There's a bias towards male children within the culture, and only 47% of couples in India use modern birth control methods, and so their population is still growing very rapidly. You can see from 2010 to 2005, there has been a shift, and so we're seeing a slowing growth in India. As the society is organizing and growing. They have a very, very large homeless population. And so homelessness is a major issue in India. And they do have leftover cultural ideas. I mean, there's definitely some religious ideas that influence some of this. If you know anything about the caste society, that does affect their population. All right, the other case study is on the population in China and how it's actually slowing down. So you have a negative population growth, and there's this comparison in the book about those two populations. This really grew out of a threat for starvation in the 1960s, and then the establishment of a very strict family planning program that was instituted in 1978. This reduced the number of children born per woman from 3 to 1.7. So the TFR was already declining, but they basically forced the hand of the total fertility rate to drop by regulating the number of children that can be born. This was a governmental decision. There were some negative effects of the one-child policy. So there became a preference for male children, and it resulted in a skewed population. There were very few females, and now people actually kind of live in this weird culture where you're competing for female mates. Average population age increasing was one of the fastest rates ever recorded, and they were able to respond to the needs of an aging population. By 2030, it's likely that there will be too few young workers to support this aging population. 2015, the Chinese government replaced the one-child policy with a two-child policy as they saw kind of the writing on the wall. And this is just kind of the new city. Oh. Okay, this picture just kind of shows like how society shifted, and with this huge influx of population, and like even in China, how during like the 1980s you had this big influx. You've got these like high-rise buildings that came out of that, and like in the foreground you can see more traditional housing, smaller community housing there. So it's interesting juxtaposition. Just kind of see that there. That's not what I meant to do. Let me see. There we go. So you can see that the age structure diagrams for China look very different, and that the sides are trend in a very negative correlation there. And so you can also see it's not as obvious, but there's definitely a percentage that is skewed more to the male side of things. So big takeaways. Human population is growing, still growing rapidly. Combination of population growth and increasing rates for resources per person is expanding our ecological footprint. This strains the Earth's natural capital. We can slow human population growth by reducing poverty, elevating the status of women, and encouraging family planning. And when we tie it all together, we know that many believe that exponential growth is unsustainable in the long run. And so employing solar and other renewable technologies to help reduce pollution is an important part of our plan going forward in developing kind of a response to the historic human treatment of the earth. Reduce, reuse, recycle, focus on preserving biodiversity, all of the sustainable issues, all of the agricultural issues, only using fertilizer to what we need. There's a lot that we can do and that we need to do in order to combat the overuse problem that comes from population growth. All right.